This is notes and examples for section 12.6, which is the sphere. So you'll need to get out your notes. So we're going to be working on the sphere section today. So sphere, the radius, diameter, you're going to see a lot of things with spheres that are in common with circles, because it's basically a series of a bunch of circles all with a common center to create a three-dimensional space. Also, if you have printed out the examples, you may want to get out the examples. So we're going to go through 12.6, surface area and volume of a sphere. So let's start with our vocabulary. So a sphere is the locus points in space that are a given distance from the center of a sphere. So a sphere has a center, just like a circle, and it's all of the points in every direction that are the same distance away from this center. So a circle is just every point on a flat surface the same distance from our circle or from our center, and a sphere is every point in every direction. A sphere, just like circles, has a radius, and just like in a radius, it goes from the center to a point on the sphere. So our radius goes from the center to a point on the sphere. We also have chords. Chords of spheres, just like chords of circles, have both endpoints on the sphere. So a chord simply has to have both endpoints on the sphere. And we have a very special chord. This one happens to be the diameter. And the special thing about the diameter is that it's a chord that contains the center. So it goes from one side of the sphere through the center to the other side of the sphere. So just like other things, or just like in circles, our radius is equal to half the diameter. We also deal with something known as the great circle. So the great circle is an intersection of a sphere and a plane, and it contains the center. So in other words, it's the largest possible cross-section circle that we can create. So if we take a cross-section that contains the center, then that is the great circle. A hemisphere, so if we actually just take half of a circle or half of a sphere, we get a hemisphere. So a hemisphere has half the dome of the sphere plus the surface of the great circle. So a hemisphere is the dome of half the sphere plus the surface of the great circle. So our formulas for the sphere, like the circle, will require one very important measurement. We're going to need to know the radius. Both our surface area and our volume formulas require the radius. So remember that the radius is half of the diameter. So our surface area is 4 times pi times the radius squared. And the volume of the sphere is 4/3 pi times the radius cubed. So surface area just uses a 4 and the pi, and the volume uses 4/3 and pi. Also notice the difference in the units. Areas are square units, and we square the radius. Volumes are cubic units, and we cube the radius. One other thing that we are going to be doing is they are occasionally going to give us the circumference of the great circle. So you may want to remember the circumference of a circle is circumference equals 2 pi r, and we can use this to solve for r. So sometimes they're going to give us the circumference of the great circle, and we're going to have to find the radius before we can calculate the surface area or the volume. So the example problems. In our first set of examples, we're going to do the surface area. We're going to use pi as 3.14. We're going to round to the hundredths. Our surface area formula is 4 pi r squared. So when we look at these problems, the most important thing we need from the picture is the radius. So in problem 1, the radius is 8. So our surface area is going to be 4 times our value of pi. So in these problems, we're using pi is 3.14, and this gets multiplied by the radius squared. So we're going to take the 8 and square it. Now that we have our calculation, 4 times the value of pi times the radius of 8 squared, and we get a surface area for this particular sphere of 803.84. It's in centimeters, and we square them. In the next question, you have to be careful because for this particular problem, this 16 goes all the way across the sphere. So this is our diameter. Our radius is equal to half of that. So our radius is 8 meters. And if you notice, our actual calculation for this problem is the exact same calculation as the previous one. We have our 4, we have our 3.14 for pi, we have our radius of 8 and squared, but it is not the same answer. It's the same number value, but it's not the same answer because this one is in meters. So while they're the same number, they are not the same answer. Same number, different units makes it a completely different answer. This is why it is super important that you remember to include your units. It's the same number, but different units. In the third example, this 11.4 goes from the center to the surface of our sphere, so we have the radius. So when we go to calculate our surface area, our formula always has pi, or 4 times pi. Pi is 3.14 according to the directions, and we're going to multiply it by the radius of 11.4 squared. Once we put the numbers into the formula, we calculate. So 4 times our value of pi times our radius of 11.4 squared. 4 pi r squared for the surface area. So our surface area of this one is 1,632 point, and we have to round. So hundredths place is a 9 followed by a 7, so we have to round 29 up to 30. Yes, you have to include the 0. Our units are feet, and areas are square units. The surface area is 4 pi r squared. When they give you the radius, substitute and calculate. When they give you the diameter, take half to get the radius, and then substitute and calculate. So 4 times whatever they tell you to use for pi times the radius value squared. Make sure you include your square units with your final answer. The next set of problems also want us to find the surface area, which is our 4 times pi times the radius squared. Once again, they tell us to use 3.14 for our pi. So our pi is the 3.14. We're going to have to use the radius, but what you're going to notice in each of these problems is we don't have a radius. In each of these problems, we have been given the circumference of the great circle. So in each of these problems, we have the circumference of the great circle. So we're going to have to use circumference to find the radius. So we're going to use circumference equals 2 pi r. So our circumference in this first one is 3 pi meters. So we have 3 pi is equal to 2 pi r. Since they leave the pi, we'll leave the pi here. So we're going to divide by 2 pi. So the pi's will cancel. And we are left with 3/2 for the radius. So our radius of this particular circle is 3/2. 3/2 is 1.5. Now we can calculate the surface area. Our surface area is 4 times our 3.14 for pi times our radius of 1.5 squared. And now we can calculate. 4 times 3.14 times 1.5 squared. So our surface area is 28.26. Since our circumference is in meters, our surface area is in square meters. Next one. Our circumference this time is 10. So 10 is equal to 2 pi r. If we put in our 3.14, we have 6.28 r. When we divide, so in the calculator, 10 divided by 6.28. Now, if you leave it as 2 pi, you have to do 10 divided by parentheses 2 times the value of pi. If you don't put that in parentheses, it would just do 10 divided by 2, and then that answer divided by 3.14. So make sure 10 divided by the entire multiplication, not just the first part. So this is going to be 1.59 for our radius. So now that we have our radius value of 1.59, we can calculate our surface area. 4 times our 3.14 for pi times our 1.59 of the radius squared. So our 4 times pi times the radius squared. We round to 2 decimal places, which is the hundredths. So this means we're going to keep that as a 5. So 31.75. Since our circumference is in feet, our surface area is in square feet. So one more time, they give us the circumference of the great circle. So we use the circumference formula. Our circumference is equal to 2 times our value of pi times the radius. And if we put in 3.14 for pi, we have our circumference equals 6.28 times the radius. We're going to divide our circumference by our 2 pi, 6.28, and we're going to round to 2 decimal places, so there's a 9 there followed by a 3, so we're going to keep it as 0.49 for the radius. So now we have, excuse me, we have our radius value. So our radius is 0.49, and we can calculate the surface area. So our surface area is our formula, 4 times our 3.14 for pi times our radius value squared. So we're going to calculate 4 times our value of pi times our radius squared. Rounding to hundredths place, so this 1 is going to round up to a 2, and our surface area is 3.02. Our circle circumference was in inches, and we're dealing with square units. So if they give you the circumference, use circumference equals 2 pi r to find the radius, and then you can use your radius to calculate the surface area. Don't forget that your surface area should always be measured in square units. So next we're going to practice with the volume. Our volume formula is 4/3 times the value of pi times the radius cubed. So pay attention to your directions. We're going to use 3.14 for our value of pi. And remember to make sure you're using the radius. So our radius goes from the center of the sphere to the outer edge of the sphere. So in problem 7, our radius is 2.2. So the volume is 4/3 times our value of pi. Directions say to use 3.14 times the value of our radius cubed. Once we have all the numbers into the formula, it's just a matter of calculating. So this one is 4/3 times our value of pi times our radius value, and on my calculator I use the caret key to get the cubed. Once again, we are rounding to the nearest hundredths, so that's the second place. Since it's followed by a 9, This is going to be 47.58. Since we have meters, we use the units, and volume is in cubic units. So since our radius is in meters, our volume is in cubic meters. Problem 8, when we look at this sphere, we have the measurement from the center to the outer edge, so we have the radius. They tell us in the directions what to use to pi, so for the volume, we substitute and calculate. 4/3 times our value of pi, we're told to use 3.14 times our radius value of 7, and our radius gets cubed. We have the numbers, so we calculate. 4/3 is 4 divided by 3 times pi. We're told to use 3.14 times our radius value of 7, and it is cubed. So our volume of this one is 1,436 point. We go to the second decimal place, that's the hundredths, and this is going to round up to 0.03. Since our radius is in inches, we use cubic inches for our answer. Be careful, you get in the habit of they tell you a number, you substitute it in, but they don't always give you the number that you need. This 12 is for the entire distance across the sphere, so that's the diameter. So the first thing you have to remember is that your radius is equal to half of the diameter. So our radius is 6 centimeters. And now we can calculate the volume. So our volume is 4/3 times our value of pi, which we're told to use 3.14 times our value of the radius, which is 6, and we cube it. So 4/3, 4 divided by 3 times pi, 3.14 times the radius, which is 6, and it is cubed in the volume formula. So our volume of this sphere is 904.32. And since this one has centimeters for the diameter, our volume is in cubic centimeters. So pay attention to which formula you're using, volume or surface area, and make sure that you're always calculating the radius. So most of the time they'll give you the radius. If they give you the diameter, which is all the way across, take half. They give you the circumference of the great circle, 2 pi r, to solve for r. So make sure you're using the correct formula as you solve these problems.